Have you ever wondering how Google create Google Maps or how people mapping some areas? Hello everyone, my name is Intan Qatrina. I am a student at Geodetic Engineering at Institut Teknologi Nasional Bandung. What if I told you everything we see on the maps is not as simple as it looks? Behind every coordinate, every boundaries, and every satellite signal, there's a science that keeps the Earth measured, monitored, and understood. That science is geodesy. So, first of all, let me tell you the definition of geodesy from each era. The first era is classical era, or before 20th century. Back then, geodesy was simple, at least in theory. It was defined as the science of measuring the shape and the size of the earth. Surveyors used basic tools like chains, compasses, and theodolites. Accuracy was limited, but it was the foundation. So, basically, geodesy in classical era is measuring the earth as a static object. The second era is modern era or 20th century. Then came technology. With the introduction of satellites and electronical instruments, geodesy evolved into something bigger. It wasn't just about shape anymore. It started to include the Earth's gravity field and precise positioning system. So basically, geodesy in modern era is measuring Earth with higher precision using advanced technology. The last era is contemporary era, or 20th century until now. Today, geodesy is on another level. We don't just measure the Earth, we monitor how it changes in real time using GNSS, satellite altimetry, remote sensing, drones, and AI. So, we can detect land subsidence, sea level rise, and tectonic movement. So, basically, in contemporary era, geodesy is understanding Earth as a dynamic, changing system. Next, let's talk about technology and development. Geodesy didn't just evolve, it accelerated. From manual measurements to satellite-based system, from days of fieldwork to real-time global data. Today's geodesists don't just work on the ground, they work with space-based technology. This shift makes geodesy faster, more accurate, and more powerful than ever. So, what is the real impact of geodesy? This is not just theory. Geodesy gives real impacts for real life, like building cities and infrastructure, mapping oceans or hydrography, monitoring disaster like earthquakes or tsunamis, and supporting navigation system you use every day. Without geodesy, modern development will be so blind. So, where does science take you? Geodetic engineering opens doors to surveyor, GIS analyst, remote sensing specialist, hydrographic surveyor, government mapping agencies, tech-driven industries like mining, oil and gas, and smart cities. And here's the truth, as the world becomes more data-driven, geodesy becomes more important. So, that's all the simple definition of geodesy from me. Geodesy started with measuring the Earth, but now it's about understanding a planet that never stopped changing. And maybe the real question is, are we just mapping the world or are we shaping its future? That's all for me. Thank you for watching and bye bye.